Welcome to Ask and Learn.
All right, so for this problem, we are finding the second difference using these same sequences from the previous problem. And so we're going to use the formula, the rule that the second difference of a sequence is equal to the first difference of that sequence minus the first difference of that sequence where we subtract 1 from n. Right, so just a refresher that the difference here, this is given by an minus 1. Okay, so these are our formulas. So in problem A, we're looking at our sequence is equal to 4. Okay, so we find the first difference here of an, so it's going to be 4 minus 4. You'll see there's no n in this formula, so any value at any value of n is just 4, which is equal to 0. And so that means that when we find the first difference at an minus 1, we get the same thing due to the lack of there being any dependence on n. Okay, so then an minus 1 minus an minus 2 is going to be 4 minus 4, and that is also 0. So we want our second difference, which is equal to the difference of an minus the difference of an minus 1. Well, that is equal to 0 minus 0, which is just 0. Okay, so we'll move on to B then. And in this one, our sequence an is equal to 2 times n. Okay, so we find the first difference. And that's going to be equal to 2n minus 2 times n minus 1. Okay, so we're going to get 2n minus 2n, but plus 2, so that is equal to 2. Okay, so then we want to find this same sequence at n minus 1. Okay, so it's going to be equal to 2 n minus 1 minus 2, and then we're going to get n minus 2 here. Okay, so we're subtracting 1 from this value, the n minus 1 value here. And so this ends up being equal to 2n minus 2 minus 2n plus 4, which ends up just being equal to 2 as well. So when we go to find our second difference, which is equal to the first difference of an minus the first difference of an minus 1, that is going to give us 2 minus 2 is equal to 0 as well. So the third case, our sequence an is equal to n squared. Okay, so we find first the first difference of an. Right, so that's going to be n squared minus n minus 1 squared. Okay, which ends up being n squared minus n squared plus 2n minus 1. Okay, and those n squareds cancel, so we just get 2n minus 1. And then we'll do the same thing for n minus 1, which gives us n minus 1 squared minus n minus 2 squared. Which gives us n squared minus 2n plus 1 minus n squared plus 4n plus 4. Okay, which gives us 2n minus 3. So then we'll put those values in as we find the second difference here, which of course is the first difference of an minus the first difference of an minus 1. Okay, so that gives us 2n minus 1 minus 2n minus 3. Okay, well, this just ends up being the two n's will cancel out, so we get minus 1 plus 3 is equal to 2. And lastly, we have the case where an is equal to 2 to the n. Okay, so the first difference, an is going to be equal to 2 to the n minus 2 to the n minus 1, which is equal to 2 to the n minus 1. Next, we find the first difference of a to the n minus 1, and that's going to be then equal to 2 to the n minus 1 minus 2 to the n minus 2, which is equal to 2 to the n minus 2. And so to find the second difference, we then take the difference of these two values. So take our first difference of an minus our first difference of an minus 1, which is equal to 2 to the n minus 1 minus 2 to the n minus 2, which we actually just did, right? That's right here. The first difference of a to the n minus 1. And so we can see that that's going to be 2 to the power of n minus 2.